So in this video, we're going to solve the equation that we discussed in the previous video, which is or we used it to calculate, or wanted to use this to calculate the temperature of the product stream of the heat exchanger. And we said that this equation is not going to be easy to solve because the temperature is present in more than one place in the equation, and this temperature is 1 raised to the power of 1, 2, 3, and 4, and it's not easy to simplify. So the simplification would be very difficult, and even if we are able to simplify it, it would be a fourth order equation, equation that has a temperature to the power of 4. So it's not an easy equation to solve. So the option that we have now is to do or to solve the equations using the trial and error method, or by iterative solution. So we'll assume a value and then change the value until the equation is satisfied. Satisfied means that the left hand side of the equation, which is this, is equal to 0, which is the right hand side of the equation. So we will have an assumption that we will use, and based on this assumption we will start our calculation. So what we know is that the temperature is less than 500 degrees Celsius. This is the only information we know about it. So I can assume any value. So let's say I assume 100, for example, and then we are going to write the equation here. This is what we are going to use to check if this assumed value is right or wrong. And this equation is the same equation that we have here. So this equation, this is going to be the longest part of the solution, which is writing the equation, because this equation is a long equation. But once you're done with the equation, everything is going to be very straightforward. So not very quick. I mean, so this is t minus 500. So of course this equation must be calculated using the value that we assumed here, because we are going to change this value later. So this is multiplied by t power 2 minus 500 power 2 minus 2.612 times 10 power minus 8 divided by 3 multiplied by t power 3 minus 500 power 3 plus 6.689 times 10 power minus 12 divided by 4 multiplied by t power 4 minus 500 power 4. So we're done with this big bracket, and then we will add 0.2 times 47.56. So this is the equation or the result that we have. So we can easily tell that this is not the right temperature, because if this is the right temperature, then this equation should be 0. One thing you need to do before you proceed is to check if the equation is right or wrong. Because one decimal place will make a big difference, one missing power will make a big difference, wrong symbol, plus or minus, will make a big difference. So you need to double check your equation, because this is the very important part. So what we are doing now is that so this is something that Excel can help us with, is that it will make it easy for us to change the number. So if I change it to 150, it's automatically calculated using the new number. If I make it, let's say, 200, then it's changing. If I make it 400, it's changing. So I can change it as much as I can, and I don't need to do the calculations each time, because it's already calculated from the temperature that I have here. But if you're going to do this manually, it's going to take a long time, because you need to change the values and see if it's getting close to 0 or not, and then it's gonna take a lot of trials. So Excel can help us to do this exercise for us without having us do this manually. Excel has a toolbox here, or an option that's called Goal Seek. If you go to Data Ribbon, then What If Analysis, then Goal Seek, you'll see here that you can check to you have three cells to fill here. So these 3 cells depend on what you want to do. So our goal is to reach or to have this equation to be equal to 0, and I want to change this cell to adjust this value. So this is exactly what we have here. So you have to set cell, which is this cell, to 0, and we are going to change this temperature. And that's all. So when you press, okay, I think there's something wrong here. So now it's D6 to 0 by changing B6. Okay, so if we click OK, then this is all. So it's done. So it did all the iterations for us. And if you check this number, you'd see it is like up to many decimal places. So it's very nice tool. You don't need to do all these iterations manually. Once you're done with writing the equations and with the settings of the what if analysis or the the goal seek option, it's going to take care of everything. So this is a very helpful tool, because these kind of equations are very common in our engineering applications. So we see these equations a lot. That's why it's very helpful to understand how to use it and to apply it to this kind of equations or any other equations. So I hope it helps, and we'll continue the energy balance in the next video, inshallah. See you then.